See, electric generator, which is called dynamo, exactly opposite to that of the electric motor. In electric motor, we said that principle is what? Conversion of electrical energy into mechanical energy. Here, conversion of mechanical energy into electrical energy. So, principle is conversion of mechanical energy into electric energy, and Fleming's right hand thumb rule. Okay, diagram. See, between two strong magnets, north and south, here we place south and north, and iron axis is capped, which can rotate freely on its own axis. This iron axis is also known as armature, as per electric motor. On this armature, a long rectangular coil is wrapped or wound. Here we show only outline of this rectangular coil. Name it ABCD. Right? Two ends of this rectangular coil is connected with slip rings. Right? Not half split ring, but full slip ring. Slip ring or called split ring, both are same. So both the ends are connected with full split ring or called slip ring. Call it X and Y. With these two slip ring, two carbon brushes are connected. Call it P and Q, carbon brushes, and both the carbon brushes are connected with storage battery, so that electrical energy whatever produced it can store. See, these two ends are connected, this touches with this slip ring and this end touches with another split ring. Okay, and this armature moves towards the turbine. See, this is strong magnet. Rectangular coil. Full slip ring. Slip is also known as split. Carbon brushes and storage battery. Okay, so you can write the construction step by step. See here, construction between two strong magnets. An iron axis is placed in such a way that it can freely rotate on its own axis. One end of this armature, this is also known as armature. One end of this armature is connected with turbine. One end of the armature is connected with turbine. Okay? On a rectangular coil ABCD is wrapped. A rectangular coil ABCD is wrapped on the armature. Two ends of this rectangular coil is touches with two full slip rings. Two ends of the coil touches with full slip ring X and Y. Two carbon brushes P and Q are connected opposite to electric motor. Two carbon brushes P and Q are connected with two carbon brushes P and Q are connected with two slip rings X and Y respectively, and carbon brushes are connected with storage battery. Carbon brushes are connected with storage battery. So this is the construction of electric generator or dynamo. Now what is the working? See, turbine, you know that, which is found below the check dam on the river. On the river, dam is there, means water is logged. Okay. Below this, there is a huge turbine. If the door of this check dam is open, then water falls on the turbine with full speed, and this turbine rotates. The big turbine is there. Okay. So when turbine rotates, this armature, one end of the armature is connected with turbine. When turbine rotates, armature rotates on its own axis. When armature rotates, then this coil ABCD continuously rotates. Now see, after every half rotation, what happens? See, when this coil ABCD rotates, then after half rotation, AB will take place of CD and CD will take place of AB. That means this portion, suppose this is CD and this is AB, it rotates like this. When it rotates like this, means AB takes place of CD and CD takes place of AB. What happens in the outside circuit? See, suppose this is the X slip ring. This end point A, my hand is coil. Now when coil rotate, means my hand rotate, then this point touches only at X. Here point A touches only with slip rings. So full slip ring, right? Now my hand rotate means coil rotate. When coil rotate, then it moves in the lower direction, and this lower moves in the upper direction like this. Okay. So after half rotation, this point moves in this lower direction and this lower point moves in upper direction. According to Fleming's right hand thumb rule, according to Michael Faraday's experiment on electromagnetic induction, we can conclude that on the basis of this strong magnet, if this coil rotate, okay, then this magnetic lines of forces moves north to south or south to north, north to south and south to north, which fluctuate continuously. It fluctuates. Why they fluctuate? Because suppose initially coil ABCD is in this manner, so north and south direction, means the magnetic lines of forces from north to south reaches to north to south. Now it starts rotating. It rotates. This is 1/4 rotation exactly at the vertical state. So north to south, magnetic lines of forces does not reach from north to south or one pole to another pole. It falls on this coil. So magnetic lines of forces decreases. When it comes to this way, then magnetic lines of forces reaches to the poles. Once again it rotates and comes to this horizontal way, then magnetic lines of forces falls on this coil and does not reach to the another pole. So in this way, when coil rotates continuously, then you can say that there is a fluctuation of magnetic lines of forces. In short, magnetic lines of forces increases or decreases. Because of the fluctuation, as you know the experiment of Michael Faraday, now you know that because of the fluctuation, what happened? Current induced. When current induced in this coil, suppose current induced from A to B, B to C, C to D and D to Y and Y to Q. After half rotation, when AB will take place of CD and CD will take place of AB. Now AB is here. After half rotation, the direction of electric current A to B, B to C, C to D, and at that time this D moves here. Okay? So after every half rotation, what happens? One time current flows in this way and Q do this. Second time current flows in this way and move in this way. That means one time current flows A, B, C, D and then Y to Q and Q to battery. Second time A, B, C, D and then P to battery. After every half rotation, the direction of electric current changes. That's why this type of dynamo is known as AC dynamo. That is called alternate current dynamo. And after every half rotation, the direction of electric current changes. If you want to convert AC into DC, means alternate current into direct current, then you have to convert or you have to use half slip ring instead of full slip ring. If you use half slip ring, then they do not change and direct current passes. So in this way electric current is produced. Now you should have to write this and afterward I write working. Okay, whatever I explained, you can take a snap also or screenshot also. Now see. Working. When turbine rotates with the help of falling water or steam, when turbine rotates with the help of falling water or running water or steam, then armature which is connected with turbine, also rotates. When armature rotates, then rectangular coil ABCD rotates. Because of the rotation of armature, rectangular coil ABCD also rotates. So, fluctuation of magnetic lines of forces occurs. So, due to this rotation, magnetic lines of forces fluctuate. Because of this fluctuation, electric current induced because of the fluctuation of magnetic lines of forces, electric current is induced in the coil. In the outer circuit, this current one time flows from ABCD YQ to battery, and after half rotation it moves from ABCD to P to battery. So in short you can write, after every half rotation direction of electric current changes. That is A, B, C, D, Y, Q to battery, and A, B, C, D, X, P to battery. Therefore, this type of dynamo is called AC dynamo, alternate current dynamo. Now, what are the uses of this electric generator? You know that electric generator, the principle is conversion of mechanical energy into electrical energy, means production of electrical energy. Here we say that turbine rotates with the help of falling water or running water or hot steam. That's why you can judge that the use of this electric generator is in the production of electricity in small scale as well as on large scale. It is also used in hospitals, operation theatre, if traditional electric current fails. In home also, in offices also, in factories also, and in hospital also, this type of generator is used. In multi-storied building, when traditional or conventional electric current fails, then to run the lift, elevators which we call, to run the elevator or lift, electric generator is used. So these are the uses of electric generator. In this way, you have to write from principle, diagram, construction, working and uses. Full 4-mark question. This is your electric generator. Take a snap and write the board work.